Hello and welcome everyone to the third lecture of the Combinatorics module of the ICO Learning Program. So this is the third lecture and this is the ZIO training series, a part of the ICO Learning Program run by CodeChef and Unacademy. ZIO is the first stage of the Indian Computing Olympiad program in India, and if you qualify you get to sit for the INOI exam. And let me introduce myself again. I'm a second year math and computer science student at Chennai Mathematical Institute, and I'll be helping you with the combinatorics part for ZIU this year. Okay, let's see. Now, the prerequisites of the third lecture is whatever was done in the first two lectures of this combinatorics module. So today will mostly be a problem session, and after the session, as always, I'll be available for queries. And please be a nice audience to me. My only expectation is that you interact with me well and keep on answering my questions as I ask. Okay. And if you have a doubt, stop me immediately in middle. Okay. As in just ask in the comments or in the questions. All right. So we will begin with a problem. I will give you a poll. Oh, hello. Yeah, I'll give you a poll. So this is the question, that how many subsets S of this set X 1 through 20 are there such that no two elements in S add up to 21, and I request that this subset S, this has exactly 10 elements. Okay, so you have the numbers integers from 1 to 20 both included, and you need to pick out numbers. You need to pick out 10 numbers. Okay, so I'm saying that from 1 to 20, pick out 10 integers so that out of the numbers that you have picked out, no two of them add up to 21. Okay, I'm saying that how many ways can you do this? All right. So I'll give you the options. So let me repeat again. The question is that you have the numbers 1 through 20, the integers 1 through 20. You need to pick out the numbers, 10 numbers exactly from there between 1 and 20. Okay, so that out of the numbers that you have picked out, you cannot find two of them which add up to 21. Okay, so is the question clear? If the question is clear, then I can proceed to the options for you to write the poll. So I'm asking that how many ways are there? Okay, let's see. Do not answer in the comments. I'll give you a poll. Okay, so these are the options, and you will have four options. Okay, you will have four options, right? And I'll give you 2 minutes to answer. 2 minutes you have in hand. The poll starts now. Okay, this is pretty much interesting. Uh, if the answers are stabilized, then I will end the poll, even if it's less than a minute that you get. Okay, the answers are still dynamic. The answers are not changing anymore. Okay, changed again. Right, nice. Okay, maybe I shall wait for 10 more. No, it's still changing. Okay, pretty interesting answers. I see pretty interesting answers. Hmm. Okay, I shall end the poll in, okay, 10 more seconds remaining. 3, 2, 1. Okay. So I'll write the results of the poll. So 15% have answered this. 46% have gone with option B. 38% have gone with option C, and 0% have gone with option D. Right. Okay. Let's see. This was a pretty interesting poll. Okay. Some guesses, maybe some sure shot answers. Let's see what answer we have. We'll look at the solution only. Okay. So group these numbers as, so together with 1, you take this 20. Okay. So this is the first group. Second group is 2 along with 19. Third group is 3 along with 18, and so on until 10 along with 17. So how am I making the thing? How am I making the groups? So I'm taking the first and the last, second number and second last number, and so on. Okay. And you can see that this 21 doesn't come out of the blue. 21 is just one more than 20, which is the largest number. Okay. So it's just 1 and 20 add up to 21, 2 and 19 add up to 21, and so on. Now, if you notice carefully that out of each group, the numbers that we pick in S satisfies that no two elements add up to 21. The numbers that we pick, the numbers that we keep in S. Right. Okay, Arav Jain, Arav was saying that initially he said that the answer was hard. As soon as I said the first line, he gave me the correct answer immediately. Good. This is a very good job. Right, this is how you need to think. You need not know the answer from before, or you need not solve the full thing, but this is how you learn. Good, Arav. Okay, yeah. So so we cannot pick out two numbers from each of these groups. We cannot pick out two of them, so we cannot take both of them. We can take at most one. Okay, but we need at least 10 exactly 10 elements, right? And there are 10 groups, so that at most one becomes exactly one now. Okay, we need 10 numbers, so exactly one number from each group, but we have two options from each group. That is, we can choose either 1 or 20, either 2 or 19, and so on. So, and it is connected via this conjunction. What is the conjunction that connects these? And or. So we choose something from 1 and 20, dash we choose something from 2 and 19, and, right? It is connected via and. Good. So 2 for this, 2 for this, 2 for this, and so on, 2 for this. So answer is 2 multiplied with itself 10 times, which is 2 raised to the power 10, which is 1024. Surprisingly, this was not the majority. This had something, if I remember correctly, it was 38% maybe. Okay, now I'll introduce you to a topic, recurrence relations via problems, so that you perceive them well. Right. Okay, so first problem is that you have this kind of a room. Okay, the length of the room is n. No. So let's see, the length of this room is n. Okay, Abhinav is asking me to re-explain 2 raised to 10. So from this group, I have two options, right? I can take either 1 or 20. Correct? From this group, I have two options, right? Either 2 or 19. From this group, two options again. and they are connected via this conjunction and. So multiply all the way up to two options for this multiply. So 2 multiplied with itself 10 times, which is just 2 raised to the power of 10. And if you calculate that, it's 1024. Right. So I was saying that, so you have this room which is of length n, and the width of this room is 2 units, n units and 2 units. So n 2 by n size room, and you have tiles of a dimension 1 by 2. So how do the tiles look like? One typical tile looks like this. Okay, you have the partition here. Maybe I'll draw the partition with green. Yeah, so just to show that these are two squares. So this is a tile. And you have sufficiently large supply of tiles. So you can get as many tiles as you want. I don't care. Let's not care about the answer now. Let's not care about the answer right now. Okay. We will come to the answer. The answer is necessary, of course, but we will come. Okay. And I am asking that. So this is later. Okay. So I am saying that with these kind of tiles, it's not necessary that it has to be vertical. Okay. You can keep it horizontal also. This is how a tile would look like in the horizontal position. Okay, with these kind of tiles, you want to place the room, you want to place it on the room so that it covers the entire room, 2 by n room. And you can keep it only horizontal or vertical. Okay, no diagonals allowed. I should have stated that. That's my bad, but okay. Now, the number of ways to tile the room. Okay, now the thing is that all these tiles are identical. Just the arrangement of the tiles, so whether it is vertical or it is horizontal, that only distinguishes, and the position of the horizontal and vertical tiles, that distinguishes. But these tiles, in all, they are identical. They look the same if you cover the room. So I am asking that how many tilings are there for this room. I'm giving you a hint that how to proceed. You call this number as xn. Okay, you call this number as xn. Let xn be the number of ways of tiling the room. Okay, so this is xn. I'm not asking you to find the answer. I'm asking you that how is xn related to smaller xk's. So smaller xk's, I mean xk where k is smaller than n. So how is the answer for this room related to the answer for the smaller rooms? And if you find that, tell me how do I calculate x8 from there. Right. Okay, some of you are already answering in the chat. That's good to see. Nice work. Okay, so what I want to send the message is that our strategy will be that if we have solved for smaller rooms, and if we relate that how my current room is related to smaller rooms, as in how the smaller rooms, the answers of the smaller rooms, they build up the current room, the answers. Then if I solve it for the smaller rooms, which are easier to solve than the bigger room. Yeah, so Adarsh, did you Adarsh says he doesn't understand. So did you understand the question? Did you understand? Okay, no. So I shall repeat the question. So I'm saying that I am tiling this room 2 by n. The dimension of the room is 2 by n. I am tiling this. Tiling with what? The only tiles I have are these kind of tiles. So I can place a tile like this maybe, or I could place a tile like this somewhere. Maybe over here I have placed a tile here. Maybe over here I have placed a tile here. Okay. So this covers everything, huh? Right. So I'm asking that how many different ways are there to place these tiles? As an overall arrangement, how many ways are there? So for example, if I have a 2 by 2 room, so this is a 2 by 2 room, right? This that I have drawn. I can either place my tiles like this. This is one arrangement. Or I can place it like this. Where my 2 by 2 room is. Draw the 2 by 2 room again. Okay. So I can place either both of them. So you can see that these two are different configurations, right? So in this case, xn. So x2 will be 2 because x2 is the number of ways to tile a 2 by 2 room, 2 by n room. N here is 2. Okay. So my x2 will be 2. I am asking that how do you relate xn in terms of smaller? As in, how do you build the bigger room answer of the bigger room in terms of the answer of the smaller rooms? Room or rooms? Okay. That is the question. So my strategy is that if I solve for smaller rooms, which are easier to solve, I can solve it for larger rooms. If I find a relation. So such a relation will be called a recurrence relation. Okay. What is a recurrence relation? That the answer of a bigger size, a problem of bigger size, over here it's a problem of size n because the room is of size n by 2, but okay, n only matters. And I am relating it to problems of smaller size. So n minus 1 or smaller. And that is what is called a recurrence relation. So how it is related to others, smaller guys. Okay. So either we can have two cases, either the leftmost tile. So we have this entire room. Okay, this is the entire room. So this is the entire room. Either my first tile, the leftmost tile that I have, that is either vertical. Okay. So I place this tile like this. I have placed it. Fine. Good enough. So I have placed my tile here. So this is covered. How much is remaining? So from here to the end, what is the length remaining? From here precisely, what is the length remaining? So this total is n, right? Total is n. Length remaining is n minus 1. So if I have covered this part, I don't have to bother about the part on the left. So I have to just tile the room on the right side of this line. What is that? That is just 2 by n minus 1, right? 2 cross n minus 1. This is 2 and this is n minus 1, this length. So how many ways are there? There is just x n minus 1 ways. Okay. Is that clear? That why there are x n minus 1 ways in case my leftmost tile is horizontal. If you have got it, can you react that so that I just understand that you are comfortable with this? Or if you are confused, you may react as well. Confused smiley maybe. Okay, someone's confused. So, okay, so confusion. Okay, let me clear the confusion. So there can be either two cases. One case is that I'll come to the second case later where the leftmost tile is horizontal. If the leftmost tile is vertical, that is one case. Okay, then I have covered till here, right? I don't need to look, I don't need to bother this part, the left part of this vertical line. I just need to bother with the remaining part. How do I cover the remaining room? Because I have already covered this region, right? So my remaining room is 2 by n minus 1. And by definition, I have told you that if the room is of size n or if the room is of size, say, m, then the answer is xm. Over here, m is what? N minus 1. Okay, so this part corresponds to this. No, xn is not n. Xn is not n. I am saying that xn is the number of ways to tile the room. Okay, so these are the two cases. Either it is vertical or this is horizontal, right? In which case, so let me get the diagram. The diagram is something like this. Okay, So maybe your leftmost tile is horizontal. So you put a tile like this. On your on the room, the leftmost tile is this thing. Okay. Horizontal. It has covered up two spaces. Okay. So maybe I will draw the two things. This is two length. Huh? But what can be placed in this position? Let me not do it green, huh? Or maybe blue. What? So the tile has to be placed in this position. But I cannot put any horizontal tiles here. I need at least two spaces for horizontal tiles. The only thing that I can do is I can place a vertical tile here. Otherwise, the room will not be covered, na? So over okay. So in the right part of the blue line, I will do that later. But in order to cover this part, because I have already placed this green, see, I have already placed this green tile. So I have to place the orange tile. I have no other option. Okay. Now I am left with the right side of the green part of the blue line, right? This blue line, this blue vertical line. Now, what is the size? What is the length of this room? What is the length of this room? Tell me, what is the length of this remaining room? Uh, it's not n minus 1. So I have placed a 2 by n, right? N minus 2. Good. It is n minus 2. Okay. Now, how many ways to how many ways to tile a room of size n minus 2 by 2 or 2 by n minus 2? It is what? Just xn minus 2. Okay. This guy. Right? Let me just clear the image up for you so that you can have a better picture. So what is the answer finally? Okay, so it is just that either this can happen or this can happen, right? And these are the only two things that can happen. So they are connected via the conjunction and or correct. They are connected via the or conjunction. So we just add them and we get that the number of tilings for a room of size n is just tilings for n minus 1 size and tilings for n minus 2 size. Is that good? Are you guys good? Are you guys good? Okay. You guys are comfortable, it seems. Okay. Okay. Yep. If you are fine, can you react your emotions or whatever you're thinking in your brain? Okay. So let me just go through this again quickly once, that either the leftmost tile is vertical or it is horizontal. If it is vertical, I'm left with a room of size n minus 1, for which the answer is x of n minus 1. Or if the leftmost tile is horizontal, say I have placed it in this green tile first, but then I don't have any other option, but to place this orange tile. I don't have any other option, otherwise the tiling will not be complete, right? There will be gaps in the room. So I have to place that. So I'm left with a room of size n minus 2, in which case the answer is x of n minus 2, and I just add them because they are disjoint cases and they exhaust. Okay, and the base cases are x1 equals to 1 and x2 equals to 2. We have seen why x2 equals to 2. So what is x1? Explicitly calculate x1. Okay, so you have a room of size 2 by 1. So something like this. This is how the room looks like. So this is the 2 by, this is 2 and this is 1. How many ways to tile this room? X0 we don't have a meaning yet, but if you want, you can take x0 to be 1. Okay, so we can just place the tile only in one way, which is to place the tile like this. Okay, that's it. Okay, yeah. So x1 is 1 and x2 is 2. And from there you can calculate, just put n equals to 3 here. You can calculate x3 equals to, you can get x3 equals to x2 plus x1. So that gives you, so it's basically x3 is the sum of previous two terms. Okay. x4 is the sum of previous two terms. Okay. So x3 is 1 plus 2, 3. And then x4 is 5, x6 is 8, x7 is 13, and it is 21. Okay, yeah. If you have seen this before, some of you might recognize this as the Fibonacci sequence. Okay, yeah. Right. Okay, now some theory on recursion, that so what do we want to achieve through recursion? We want to define a sequence of array, right? We want to define a sequence or an array in terms of itself, right? In terms of the problem, so that we look at a problem in terms of its sub problems. Okay. Now so you saw it through the previous problem example. Okay. Now how do we find a candidate? So how do we recognize that this problem is solvable by recursion, or I can use recursion to solve this? We will cover this will be covered more in details in DP with more practice problems. So I have borrowed this from brilliant.org. These are the exact points that are stated. So you check if the problem can be reduced to simpler cases. So I solve the smaller problems and then I combine them to get the larger problem. And to each problem, I can associate a size to that problem, right? Which is maybe say, which was n in this case. But it need not be n every time, as you will see in maybe the DP sessions. So sometimes this numerical value can also be a tuple of integers, maybe a pair of integers or a triplet of integers and so on. And with a smaller index, maybe say with a smaller index, say of n, so a problem of smaller size is easier to solve than a problem of larger size. Okay, so if you see these things in a problem, you will understand that, yeah, I can solve this via DP, right? Or via recurrence, say recurrence equation or recurrence relations, or which are also you'll learn as DP. All right. Now let's again practice. So as I promised, everything today mostly will be a problem, except that part itself, except just the previous maybe. Yeah. So my question is that, again, there will be 3 poles now. How many subsets of 1 through n are there which have the property that no two consecutive numbers appear in that set? Okay. So maybe say I take the numbers 1 and 2. The only required subsets will be either the set 1 or the set 2. I cannot have 1, 2 as a subset because that is not allowed, right? Okay. So let me, okay, so I should, so I'll give you the values for 4 and then I will ask you to compute this. Okay. Right. So I should say non-empty. Should say non-empty. Better. Okay. So the poll will be for 30 seconds. Your poll has started. Maybe choose. Yeah. Okay. There's a good fight. All right. Um, okay, maybe for the others I will add an option. Okay, so option E, I will put one option. Nota. Okay, so these are the options. Hmm. So right. So this is the poll for now. I will be conducting the poll for n equals to 6, and I'll give you 45 seconds. You will have 5 options. Okay, 45 seconds. I will not tell you the answers right now. Again, okay, the poll has almost ended. Okay, so majority has chosen E, nota. Okay, now I will conduct the poll for n equals to 8. Okay, for n equals to 8. Again, you will have 45 seconds. Okay, nice. The poll is going pretty well. Okay, 13 seconds. All right. Okay, good. Um, yeah, I don't want to put this. Okay, let's see. Okay, sorry. Empty sets are included. I'm sorry, but okay. Nevertheless, uh, this was just to make you think and not just the answer. So, so those who have chosen some answer or those who have voted for the poll, can you like share your thoughts? So, what have you tried to do or something? So, how did you choose your answers? Anybody want to share their thoughts? Okay, so someone says brute force, manual count, just sound possibilities. Okay, yeah, this is more what many of you have done. Okay. No, for n equal to 4, the subsets, there can be more subsets, right? So the subsets named 1, 2, and 3. So the set 1, set 2, and set 3, right? They are different. So again, I should add another option here, nota. I'm sorry, I messed up with the options actually. Here, I forgot to add nota. Correct, correct. Okay, someone has observed something. That I'll come to this. So this is how we will get the solution. That we try to find a recurrence for Fn. What is our Fn? Fn is the required answer. Okay, so number of subsets of 1 through n when the when we cannot take any two consecutive elements. So let that be Fn. Now there can be two types of acceptable sets. So acceptable sets in our case means that what sets we want. That is, they do not have any elements which are consecutive, right? So either the subsets contain n, the subsets. So a subset you can divide into two categories. Either they contain n or they do not. Okay, cool, fine with that. Okay, if they contain n, how many of them are there? Tell me in terms of f of something. So tell me that f of something plus f of something into something, like this. Tell me an answer like this, that these many subsets do not actually contain n in them. So n is present in them. Not n subsets. Okay, someone has said f of n by 2. Any other guesses? F of n minus 2 by 2, that is another answer. Okay. Okay, someone has said n minus 1. I'm asking how many subsets? F of n minus 2. Okay. Okay. The question is that, you mean the question right here, right? Okay, so I'm asking that if you guarantee that n is present in the subset, okay, how many such subsets are there which contains n? How many such acceptable subsets are there? That is good subset. Okay. Yeah, so if n is there, then n minus 1 cannot be there because two consecutive things can't be present. So it is same as, yeah, that is a particular subset, right? Empty set is also a subset. Okay, so that is same as choosing the number of good subsets from 1 through n minus 2. Okay, so n minus 1 is there in the subset. N minus 1 cannot be there. So what are the remaining possibilities? One for each of the good subsets from good subsets of 1 through n minus 2. Okay, so that gives f of n minus 2 of them. All right. All right. If we have this, so n is present, n minus 1 cannot be present. How many? So for the remaining elements, how many can be there? It is just f of n minus 2, because I want from 1 to n minus 2. Okay, yeah, f of n minus 2. Another case is that n is not present. If n is not present, how many such subsets are there which do not have n in them? F of n minus 1, correct. It's just f of n minus 1. Anything can happen. From like leaving out n, anything can happen. Okay, now let's see. So this, so now what does this do? Okay, so these are disjoint cases, right? These are disjoint cases, and these exhaust. So connected via the conjunction or, which means we add them. So again we get this Fibonacci recursion. What are the base cases? We need some base cases, right? We need base cases. I haven't written down the base cases. So if my subset is, if my set is 1, with, yeah, so for 1, how many are there? There are 2 of them. Either the empty set, okay, why should we get it +1? Okay, why should a +1 be there? Okay, so for this set containing 1, we can either have the set empty or we can have just 1. Okay, so yeah, so I am considering just n because I have allowed empty set. Yeah. Wait, I have actually allowed empty set because if this empty set is counted in fn minus 1 and n is already, and I guarantee that n is always present, so that makes it n, right? I am allowing empty set. And so if I have 1, 2, then what is it? How many sets are there? There are you can either have the empty set or 1 or 2. So there are 3 of them. Okay. And now this continues as Fibonacci. So this is a 2, 3, and then 5, 8, etc. All right. No, it's fine if you ask your doubts. Okay. Now, and it is not, okay, what is for 0? So if you have the empty set, it's just 1. For the empty set, it is just 1. 0 corresponds to empty set, right? Yeah. Okay. Now, so you guys are spotting out some errors. So which part do not? Okay, so if it does not contain n, so what do? I just ignore n. So I'm just looking at 1 through n minus 1, right? And what am I doing? I'm just looking at all the good subsets from 1 through n minus 1. Okay. Right. I will give resources at the end. So let us look at a ZIO problem in which we will use the previous problem. So n people are sitting around in a circle, and it's like, okay, if n people are sitting around in a circle, so each has exactly 2 neighbors. Cool with that. How many ways can you pick a non-empty subset of these people? Okay, you want a non-empty subset so that no 2 adjacent people are selected. Okay, 2 side-by-side people cannot be taken, and you want a non-empty subset. Here, okay, here non-empty is important. Previous one we allowed empty. Here we do not allow empty. Okay. The solution. Okay. The solution is pretty simple because you label the people 1 through n. So you have 1 and then 2 and then dot dot dot, n minus 1 and then n, and beside n is 1. So 1 is sitting between n and 2. Okay. Now I look at, it is quite similar, but the thing is that when you remove one person, it breaks into a line, like it breaks into a single chain. Okay, so that is why. Okay, let's see what happens if you look at specifically 1. He is either there or he is not there. He is either there or he is not there. Okay, if 1 is chosen, if 1 is present in the subset, so I'm choosing 1. I cannot choose 2, I cannot choose n. So 1 has been chosen, I cannot choose 2, I cannot choose n. From the remaining, that is n to n minus, 3 to n minus 1, okay, they form a line because 3 over here does not have a neighbor to one side and n minus 1 over here does not have a neighbor to the other side. So they literally form a line. Okay. So how many ways are there to choose? So 1 is already chosen. How many ways are there to choose people from here? It's just the same as choosing from the set 3 to n minus 1. How many is it? It is f of n minus 3. So if you count how many elements are there in this set, it is exactly n minus 3 elements. So that is f of n minus 3. But here f is as in the previous problem because we are looking at a line. So it's like this, right? It's a line like this because this guy doesn't have anyone here and this guy doesn't have anyone here. Okay, so it's basically a line, linear arrangement. So that gives f of n minus 3 ways. Okay, and if 1 is not chosen, we need to find the number of non-adjacent people. Literally, we remove 1. Remaining are 2 and n and everything between them. So it is guaranteed that 1 is not there. Okay, so it is just 2 to n, 2 up till n. And I know that 2's neighbor 1 is not there and n's neighbor 1 is not there. So it is just 2 to n ka subsets, good subsets, that is n minus 1, that is f of n minus 1, where f was the previous guy. Okay, f was the previous guy. All right. If f was the previous guy, right. Now we had allowed empty subsets in the previous f. Okay, now in this case there are no empty subsets because I'm guaranteeing that 1 is there. But in this case there is one empty subset which is chosen. So what I do is that I add these two and I exclude, so I add these two and I exclude the empty subset. So your final answer is exactly this thing, this box thing, where how do you compute f? F is the Fibonacci sequence which was there shown in the previous slide. Okay, the Fibonacci sequence where f1 is 2 and f2 is 3 and so on continues. Okay. Okay, those who are confused, can you tell me exactly where you are confused? That would be helpful. So it's either two cases, that one is chosen or one is not chosen. If one is chosen, you are reduced to 3 to n minus 1, which are in a line, and the number of good subsets is f of n minus 3. So this is not a recursion. This is not a recursion. F has been already computed before. F was what? F was as in the previous problem. Okay. Cool. And that f, using that f, we answer this problem. Because removing, so in a circle, if you remove one element, it basically breaks the circle into a chain like this or a line. Okay, yeah, so this is how it's done, and you remove this one for the empty subset, right? Okay, now the next problem is that I have written some numbers on the board. Okay, 1 through, okay, I have written 4 ones, I have written 4 twos, and I have written 1 4. Now what you can do is that from here you can take any numbers. So suppose say I take this number and this number, I take 2 and 4. So these are A, B, and instead of A and B, I erase both A and B and I write AB plus A plus B instead of them. Okay, maybe someone, okay, so maybe first I choose 2 and 4 and instead of that, right, 4 into 2 plus 4 plus 2. And then maybe again do that same thing with any other two numbers which are now written on the blackboard. So previous two numbers have been erased and one number has been written, and you continue this until one number is remaining on the blackboard. Okay. Now it might happen that if you follow a different sequence, so what someone is doing is that okay, what someone is doing is that maybe they choose 2 and 4. Maybe I choose 1 and 2. Maybe someone else chooses 1 and 1. So that gives a different sequence, right? So maybe the last number that is remaining, maybe it is different. Maybe for me, the last number is different. Maybe for them, the last number is different. Because you can see that it kind of depends on the order. I'm saying that I'm taking any two numbers. Okay. Now, what we should do is, I am asking you the question that which of the following numbers, I'll give you 4 options, and I'm telling you that this time I haven't messed up, so one of them is correct. Which of the 4 options is a possible number that can remain in the final step? That is some person can do, like, can find a sequence of steps that they remove these two numbers and adds one, and then they remove another two numbers. So some sequence leads to that final number. Okay, that is the question. So which of them are possible? I will give you 2 minutes for this. So the poll, right, let me just set up the timer, and 120 minutes. And there are 4 options and the time starts now. Maybe you can use your calculators if you want, because ZIO does allow calculators. Okay, I see some interesting things. You still have 65 seconds or so. You still have 43 seconds. Uh, 15 seconds. Okay, so all 4 have got answers. Right, right. Poll has ended. Poll has ended. Okay, okay. Yes, yes. Okay. So Sriteja has got it. Right. So let me tell you. The correct answer is what? No, I won't tell you the correct answer. That's a surprise as well. Okay. So let us see what we are doing. So what we are doing is picking out A and B, and what we are doing with them, we are just looking at this number, A plus B plus AB. If you tweak it a little bit using some algebra, you will see that it is something like A plus 1 times B plus 1 minus 1. Okay, expand this and check. This is easy. Okay, Now, maybe at some stage you are doing it. At some stage, I will extend. Okay. So at some stage, you find that your numbers on the blackboard are A1 through AN. I don't care what A1 through AN is. I'm just saying that maybe it is A1 through AN at some stage. Then I'm asking you to look at this quantity, that you add 1 to every number on the blackboard and multiply them. Okay. So successor of each of the numbers and the product of those, product of the successor. Okay. I am just asking you to take a look at this for now. So keep in mind, just keep in mind as a buffer. This will load in some time. Now, so we have these numbers A1 through AN and we choose two of them, say AI and AJ. And without loss of generality, AI comes before AJ. In that case, we are deleting AI and we are deleting AJ and writing this AI star AJ number, which is equal to A1 AJ plus 1, which is equal to AI plus 1 times AJ plus 1 whole minus 1. This is the number that we are writing instead of this. So what are the new numbers on the blackboard? So the new numbers are this new number, this number that we have written here. So we have deleted AI and AJ and we have written this number. So this is maybe this number we have written. And then A1 is there as usual. All the numbers are there, but over here note that AI is absent. And over here AJ is absent. And all the numbers are as usual present. Okay. Now, what is the product of successors of these new numbers, which are written on the blackboard? What are the product of the, what is the product of the successors of these numbers? What is the product of the successors? Okay, you add 1 to everything over here. So you add 1 to A1 to AN except AI and except AJ and multiply them. And you add 1 to this also and product that. Put it as a product. So everything except I and J, you take a product of that. Right? And this new number that you have written. Okay. So what is this number? Does it change? What is the new product of successors? Correct. So this is exactly this previous guy only. Okay, which is just X. So what I am saying is that irrespective of which two numbers you choose, this quantity over here, that product of successors of the numbers on the blackboard, currently on the blackboard, at every step that is exactly the same. That does not change. It is an invariant. It remains invariant. So variant means changing, invariant means not changing, does not change. Now, what is the product of the successors of the numbers in the last step? So in the last step, what do I have? I have just one number. What is the product of the successor of this one number only? So if my last number is A, what is the product of successors? It is just A plus 1, number plus 1, right? Okay, but what did I see? I saw that this number, this product of successors is always X, no matter in what way I choose the numbers on the blackboard, two of them, or right, to replace two of them. Okay, no matter what. So it must happen that whatever this big equation. So what I have done is that taken every number from 1 to n except I and j. I have taken every number from 1 to n, added 1, multiplied them. So which is the product for these numbers. So product of successors for these numbers on the blackboard. But I need for every number. So I add 1 to this highlighted number, and then multiply with the rest. And now, so if you look at this, so +1 and -1 cancel out in this region, in this part. Okay. Okay. And this product, this had INJ missing. INJ is supplied from here. So it is basically the product of everything from 1 to n. So everything as in A1, AK plus 1, where K varies from 1 to n. Everything, all the numbers, without exception. So INJ were missing initially, that I got from this. Okay. So I see that X does not change. So whatever is X in the end, namely A plus 1, that should be X in the beginning also. What was X in the beginning? Let me remind you the numbers in the beginning. What was X in the beginning? What is X for these numbers? What is X for these numbers? So it is 2 raised to power, no, it is 1 plus 1 power 4, because 4 of them are here. Then 2 plus 1 power 4, and then 4 plus 1. Which if you calculate, it comes out to be 6480. But this should be equal to A plus 1 because it never changes. So A is equal to 6479. So your correct answer was D. All right. Okay, this was a pretty nice problem. And the final problem for today. So, okay, Arav, what did you not understand? Can you tell me explicitly? Which part should I re-explain? So I started, so I'm saying that look at the quantity. So if you have, okay, if you have numbers written on the blackboard, look at the product of successors. I'm saying that at every step, product of successors of the numbers on the blackboard currently at every step, that never changes. So whatever it was initially, it should be the same at the end. Initially the number was initially that product of successors, that was 1 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 1 times 2 plus 1, 4, like that, multiplied 4 times to itself, and 4 plus 1. Okay, in that case, if you multiply, it comes out to be 6840. But I am saying that the product of successors never changes. Finally, if the number is A, if the number remaining is A, product of successor of that number is just A plus 1. So A plus 1 must be equal to X. X remains constant at every stage. Product of successors remain constant at every stage. That is what I have calculated over here in this big equation. Okay, that it is the previous X only. So product of successors for previous blackboard was this. The new blackboard has these numbers. The product of successors for that is this expression, which if you simplify comes out to be the previous X only. So initially the numbers on the blackboard were A1 to AN. Product of successors for those numbers was this. So take plus 1 and product. Now I'm saying that you do that operation, pick AB, exchange that. So you pick AI and AJ, and if you exchange that, the new numbers on the blackboard is this. Product of successors for these numbers, these highlighted numbers that are currently on the blackboard. So it is there on the YouTube link only, or it will be available in Unacademy only. Okay, so these new numbers on the blackboard, this thing, right? This is the product of successors for the current numbers that I have on the blackboard. And if you evaluate that, it comes out to be the previous X guy only. So I'm saying that product of successors never changes. So successor means if A is a number, successor of A is just the next number which succeeds A plus 1 in natural numbers, of course. Okay. Right. And the last problem. So again a poll I'll give you. How many tuples of integers a1, a2, a3, a4 are there such that these are non-decreasing? So 0 less than a1 less than equal to a2 less than equal to a3 less than equal to a4, and they are between 0 and 8 inclusive of both. Okay. So some of you might have tried the problem set that was posted yesterday night. It is exactly similar to the so re-explain. Okay, I'm looking at the tuples of integers, ordered pairs of integers, ordered sets of integers a1, a2, a3, a4. Okay, and they satisfy this thing that they are non-decreasing and they lie between 0 and 8. So how many such ordered sets are there? Ordered, so we're ordering. Okay. Now, no, perhaps one example is say maybe 0, 0, 0, 0 is one such example. Another example is maybe say 1, 2, 3, 3. Maybe another example is 7, 7, 8, 8. Maybe another example is 0, 0, 7, 8. So how many of these can I enlist? So it will satisfy all of this condition. 4 numbers. Okay. I will give you 2 minutes again for a poll. Options are here. Poll is 2 minutes. Okay. So this time you will know the correct answer because I am marking it. Okay. So poll has started. I think only 2 people have answered so far. Okay, someone else has also answered. Right. Okay, we have some interesting answers. Okay, few seconds. 10 more seconds. All right. You can use a calculator, of course. Okay. The correct answer is so I will tell how many percent have answered. 33% of the people have answered this. 22% of the people have answered option B. And an amazing 44% have answered options. So before going to the solution, I'll tell you how the structure of the solution looks like. It is simply what this. I will tell you how the solution looks like. All right. Okay, Sachin on YouTube says 126. All right. So maybe percentages will change a bit. Okay, good. All right. So let's see. We will just solve it by making it a general statement, because often in ZIO you will need to make a general statement and solve in general, because some test cases will be so hard that you cannot brute force. So in ZIO, word of caution, part A will be easy, you can brute force. Part B will be somewhat intermediate, brute forceable, but that will force you to make it into a general problem and solve. Part 3, almost impossible to solve using brute force or just counting one by one. This is the general trend in ZIO. All right. So we denote by DI the quantity that how far is AI from AI minus 1. And so that is how far is A1 from A0, how far is A2 from A1. So I have A0. A0 I am putting it as 0. Okay. A0, and then I have A1. What is this middle part? So I have A1 over here. What is this middle part? I have A1 over here in my thumb. And then I have A1 here. I have A2 after this distance. So this is my A2. And then A3 after distance D3. Okay, and so on. So D1 is this. D1 is simply A1 because it's A1 minus 0. D2 is A2 minus 1. A2 minus A1 up all the way up to Dn being An minus An minus 1. And what is Dn plus 1? Dn plus 1 will be the distance from Am to whatever, how much maximum I can go. I can maximum go up to M, right? So I have An here, and I can go further till M, a distance of Dn plus 1. Okay, that is the distance I'm getting. All right. Now, so if I have these, if I have these AIs, I can get the DIs. I can find the DIs. Okay, I can find the DIs. As in, I can find the distances if you give me the numbers. If I give you the distances, okay, distances, of course, subject to something, that subject to this thing. So subject to the fact that M is the sum of this, subject to the fact that M is the sum of this, and the DIs are non-negative. Can I find the numbers AI? Yes, I can, because D1 is just A1. So 0 till A1. Okay. So 0 till A1. So I'm saying that if I give you the numbers, I give you this A1, after that A2 is there, after that A3 is there, and so on. I'm saying that you find the distances between them. Okay. Now, instead of giving the numbers, I give you the distances. So I'm telling that from 0, the first number is at distance D1. Okay. Now from the second number, whatever the second number is, or whatever the first number is, okay, whatever the first number is, the distance of the second from the first is D2. I'm telling you what D2 is. Suppose I tell you. And then I tell you what D3 is, D4 is, and so on. Can you figure out the numbers? Can you figure out what is the first number, what is the second number? So the first number is just D1, right? So it's 0 distance from D1. So it's just D1. What is the second number? So you first covered D1 distance, and from you reach the first milestone. From there you cover D2 distance. So you have reached the second number. That is the second number, D1 plus D2. And then you cover another D3 distance. You reach the third milestone, which is D1 plus D2 plus D3, which is the A3, number A3, and so on. But they should be conditioned to the fact that M equals the sum of these distances. Okay. So what it reduces is that finding these AJs. So if I giving you the milestones is the same as giving you the consecutive distances between each pair of like each consecutive milestone or each adjacent milestone. Okay, but I should tell you that the sum of these distances between consecutive milestones up till m, they should add up to m, and the distances between each milestone is, as it goes unsaid, it's at least 0. So it is equivalent to solving the equation. It is equivalent to solving the number, finding the non-negative integer solutions to this equation. Okay, finding the number of non-negative integer solutions to this equation. All right, if we have found the non-negative integer solutions to this equation, so each solution gives you the distances between the corresponding milestones. So that will give you where the milestones are. And we have already seen from the last class that the number of non-negative integer solutions to this equation is exactly m plus, so number of variables minus 1, choose number of variables minus 1, which is simply m plus n, choose n. Right. What was my m plus n, choose n? Let's go back to the problem again. So m is this, n is this. So in my previous problem, what was m and n? M was 8, n was 4. So 12 choose 4 was the answer, which comes out to be 495. All right. Okay. So with this, I will be ending the lecture today. I will be still hanging around for a while, maybe 5 minutes, but these are some of the resources. So Art and Craft of Problem Solving by Paul Zeiss is a very good resource. So with this, we have come to the end of the Combinatorics module for the ZIO Learning Program as a part of the ICO series. Some resources are Art and Craft of Problem Solving. Some resources are Problem Solving Strategies by Arthur Angel, which is a bit harder. And these are the contests. Okay. And these are clickable links given in the PDF only if you get the PDF. All right. And my Discord handle is Luida, and I am available on the server with the nickname Nilava Metya. Also, please fill up the feedback form. And in case of, I should say that this first book is a good book for learners. And this second book is a good book for practice. Once you have learned something, some non-trivial amount. First book is learning by problem solving. Okay. Right. Okay, is my spelling incorrect? Okay, but the name of the book is Art and Craft of Problem Solving. Right. Okay, the spelling is incorrect. Okay, so if you have questions, I'll hang around for a while. Okay, someone says love the LaTeX. Thank you. Also, please remember, please fill up the feedback forms. And you can maybe contact me on Discord. So I may not reply immediately, but I will reply at some point. Maybe within 48 hours, I'll reply. If not, then I shall end the session. If no questions. Thank you everyone for being a great audience, and it has been lovely to interact with you all. And I hope I can see you in the future as well. Till then, bye. Goodbye everyone and have a good evening. Thank you.